Okay, so for question 12b, we have f of xy equals to 2x minus y squared. And then we have region R, segitiga yang bounded by these three bucu. So, kalau kita lukis di segitiga dalam xy plane, then we have this segitiga. And then so untuk cari maksimum minimum mutlak, so first we need to find the maximum minimum relative inside the region. And then maximum and minimum value at these three boundaries. So let's define these three boundaries as A, and B, and then C. So now let's find the maximum minimum relative first. So for that one, we need to calculate fx and fy. So fx is equals to 2 times 2x minus y, and then times 2, which is equals to 4 times 2x minus y. And then fy, division with respect to y, we have 2 times 2x minus y, and then times minus 1, which is minus 2 times 2x minus y. So we equate both equals to 0. We have first equation, second equation. So for equation 1, we have 2x minus y is equals to 0. And then for equation 2, we have 2x minus y equals to 0. And then as you can see, we have same. So these two is actually represent the same line. So they intersect at each point on that line. So the line is actually y equals to 2x. So if we try to draw this line inside this one, sebab kita nak tahu which x yang inside this region R sebenarnya. So this line is actually this line. Dia punya intercept dekat 0, and then when x equals to 1, then we get y equals to 2. So actually values of x varies from this intersection point up to this 1, 2. So nak dapatkan this intersection point, so kita kena dapatkan line untuk B ni dulu. So untuk B, so the gradient is equals to this 1 minus 0 over 0 minus 2, which is equals to minus 1 over 2. So then we have y equals to minus 1 over 2x plus 1. And then we substitute y equals to 2x into this y. So we have 2x equals to minus x over 2 plus 1. So then we get x is equals to 2 over 5. So the maximum and or the minimum relative for this function dekat dalam region ni is actually equals to y equals to 2x, where x is in between 2 over 5 to 5. So this one. Okay, now let's calculate the maximum minimum at each of these boundaries. So let's start with A, and then A is from 0.01 to 12. So A is from 0.01 to 0.12. So for this one, we have straight line with M is equals to 1, and then Y is equals to X plus 1, where x is in between, x is between 0 up until 1. So if we substitute this y equals to x plus 1, so we have f of x, and then y equals to x plus 1 into the f of xy. Then we have 2x minus x plus 1 squares, and this one is equals to x minus 1 squares. As you can see, this one is a quadratic equation yang smiley punya face macam ni. So meaning that we have a minimum. So now we need to calculate the minimum value and then check whether this minimum value lies inside in the region R. So untuk dapatkan minimum value, so we need to differentiate f with respect to x. Then we have 2x minus 1, and then we equalkan kepada 0, then x is equals to 1. So x is in between 0 to 1, so x is equals to 1 is inside this region R. So when x is equals to 1, then y masukkan balik dalam this one, then y equals to 2. So sebenarnya point kita ada is 1, 2. So this one is the minimum, which is actually the bucu lah, one of the bucu. So meaning that the other bucu, which is 0, 1, this one will be the maximum untuk this boundary.